Good morning again, everyone. Welcome to today's webinar, ReefShape, Discover the Future of Coral Reef Monitoring. Our speaker today is Will Greene, who is the photogrammetry specialist here at the Perry Institute for Marine Science. So before we get started, we just want to go over a few housekeeping rules. Please note that this webinar is being recorded, and a reminder to keep your microphone muted during the session. Afterwards, there will be a Q&A session, and you can add any questions that you may have into the chat, or additionally, you can raise your hand, as well as an audience feedback link will be shared in the chat towards the end of this webinar. So if you all can fill that out, that would be greatly appreciated. So without further ado, I will now welcome our speaker to begin their presentation. Will?
Thank you, Danielle. Welcome, everyone. I'm so glad we've got a lot of folks here. Let me just get my screen share started and we'll get going. All right, Danielle, can you see my screen all right?
Yes.
Okay, wonderful. All right, well, let's get going. So as Danielle said, the topic today is ReefShape, which is our photogrammetry system that we at the Perry Institute have been developing for a long time, pretty much since I started at the Perry Institute, or even started working with the Perry Institute back in 2019. ReefShape is really the culmination of a lot of the work that I've been doing, and I know that there are many people on this webinar who have maybe seen bits and pieces of this, but we're sort of finally getting to the point with it where it is somewhat production ready, and I'm really excited to share this tool with all of you that I hope can help you to advance your coral reef monitoring toolkit. So let's get moving. So we'll start just with a quick overview. So what do we want to accomplish today? I've got about 45 minutes that I'm going to try to be chatting for, and then we're going to have some time for questions. So we'll start with just a bit of framing what the purpose of ReefShape is, and what problems it solves, really. And then I'll talk a little bit about large area imaging or photogrammetry, and just give an overview of what that technology even is. And then I'm going to really dive into the nuts and bolts of ReefShape, and give an overview, talk about the materials that you need to get up and running with it, and then talk about the underwater methods that we use to collect data, the computer methods that we use to process it, and then I'll talk about some analysis options for large area imaging and photogrammetry data. And then hopefully we'll see what we have time for, but I'll give a little demo of what data will look like once it's done using this system. And then I'll talk maybe a little bit about how you can actually install it and use it yourselves. So at a basic level, just to frame things, coral reef monitoring traditionally has been done largely in situ. And that means folks scuba diving or snorkeling with pen and paper, waterproof paper, and writing things down, taking measurements underwater, doing line transects, things like that. And that is, has been a great way for us to collect data for a long time. And so there's a long time series of data collected like that we, the collective reef ecology community, has. But there are some challenges that are associated with that. First of all, it's challenging to do good time series monitoring unless you have permanent transects set up, which is often not the case. It's also challenging to monitor things at scale, and especially in the face of needing to do a lot of coral restoration and the movement that's building up surrounding that. There's a lot of monitoring that needs to be done of coral restoration efforts that are just really challenging to do by even a team of divers underwater writing things down. The other thing is it's very dependent on what actually gets collected underwater. You'd never have an opportunity to go back in time and collect different information. There's also the methods that we've used to collect information on structural complexity in the past have been somewhat limited. And that is challenging because structural complexity is, of course, a really important metric to understand in terms of habitat quality for other reef inhabitants. And what we're trying to do here is really address a solution for monitoring at the human scale. So we have all sorts of technologies to monitor, from a remote sensing scale on broad scales, and then also down to like microbial scales. There's other toolkits for that. But what I'm trying to target here is sort of human scale monitoring. What I mean by that is the scale at which we actually see things with our own eyes, on the order of hundreds of square meters at a time. And so I'm far from the first person to think about using photogrammetry as a solution to this issue. So photogrammetry is a technology that has been developed for a really long time, and it has a great application for coral reef monitoring. And what do I mean by that? So the sort of term that many folks may have heard is the photomosaic. And what a photomosaic is it's collecting overlapping images of an area that you can then stitch together into a synthetic image that covers an area that you couldn't possibly capture in just a single frame. And that's why the term large area imaging is particularly applicable to this. But a lot of folks also just call it, as sort of a blanket term, photogrammetry. You've probably also heard the term structure from motion. What that means is it's the type of photogrammetry that's being done here. And that means you're moving the camera and taking a whole bunch of photos from different angles. And by using computer software, it can analyze the overlap between those photos and actually reconstruct the in 3 dimensions where all of those photos were taken from, and then where all of the subject that you actually took photos of, what that landscape or reefscape in this case looks like. There's a whole bunch of different little elements of the photogrammetry or large area imaging process. And that's what I have a figure of here. The first part in the traditional photogrammetry process is tie points and camera positions, which you see in the panel A. And then the second thing is actually building a reconstructed 3-dimensional surface. In this case, a mesh model. That's what you see in panel B. The third thing is an elevation model. This is a 2-dimensional top-down image that actually represents how deep each part of the image is. That's in panel C. And the final thing is an orthomosaic or photomosaic. And what that is that top-down 2-dimensional synthetic image of the reef plot that you've photographed. And that's in panel D. So in effect, the way that I like to think about this technology is that it enables us to create a digital copy of a reef, of an area of reef. And it transforms the sort of paradigm of collecting data, where instead of collecting the actual ecological data underwater, we're collecting photo data underwater, and then saving the ecological data collection and analysis for doing on a computer ex situ. And what's really amazing about that is that you don't actually have to choose the exact analysis that you want to do when you're underwater. Once you have this digital reef replica, there's a whole slew of different types of analysis that you can do on this data. And I'll touch on that a little bit later in the webinar. So there's a few challenges and barriers that are associated with this. This sounds great, right? It's a really cool technology. It's been really taking off in the last decade or so. But there are some challenges associated with it. One is that there's a very steep learning curve to actually use the software that you need to process the data and even to just collect the data properly underwater. And there's also a whole bunch of different methodologies for doing this, some of which are really complete, some of which are sort of like allow the researcher to choose their own path a bit more. And that creates a lot of confusion. The process for actually processing the data is also really time consuming, and that's because it's very resource intensive for the computer. There's a whole bunch of different steps, which I touched on a little bit. And each one of those steps can take, many, many minutes, 20 minutes, half an hour, and up to several hours. And what that means is that somebody needs to be present to actually help shepherd this process along. And that just takes a lot of time. A person might not be spending that much time actually typing on a computer to deal with it, but they have to be present to ferry the process along a bit. It's also very challenging to automate underwater photogrammetry. And there's a whole number of reasons for that, which I won't really get into. But suffice to say that enabling this process to be done without any user intervention that results in data that's fully usable is really challenging. It also can be very expensive. A lot of folks use very expensive camera systems. You need to use fairly powerful computers, and the software also costs a decent amount of money. Time series monitoring is also a challenge with this. And by that, I mean actually aligning data sets through time, aligning these three-dimensional models in digital space is challenging. And we all know that reefs change a lot over time. And so it's sometimes you really need to have some fixed points on the reef that you know exactly have stayed static to enable us to sort of overlay time points of imagery. Data management is also a challenge here. This generates terabytes of data. And also processing all of this data in the exact same way every time so that you have, a repeatable, consistent process is challenging. And sort of the result of all of these challenges is that a lot of folks are able to make basic photo mosaics, right? But a subset of those people are actually able to collect real world ecological data that's what we're really after, right? That's the key thing, is we want to learn things about how reefs are changing and what their condition is that we wouldn't have been able to do with just in situ underwater data. And it's challenging to actually get to that point, to collect that type of data. And so in my view, we really need a systematic approach to address all of these issues. I started at the Perry Institute in 2019, and sort of my very first project was helping to develop a protocol for this type of process. And so in working on this since 2019, ReefShape is the culmination of what we have come up with to address all of these challenges. It's designed to be a comprehensive solution, providing guidance on the underwater process and the computer process. It's designed to be efficient and repeatable through automated processing. So rather than having users decide on all kinds of different parameters, a lot of that is scripted out and automated. So you don't have to choose that every time. It just processes your data consistently. It also includes a very straightforward georeferencing process so that your data comes out with real world GIS coordinates that you can compare it to aerial imagery and any kind of other GIS data. We've also designed it to be as flexible as possible so that different research groups can make use of it, even if they aren't using exactly the same equipment or exactly the same minutia of the protocol. As long as they follow some basic key steps, they're able to make use of this software package. We've also designed it to be easily integrated into common analysis workflows, such as point counting in a GIS software, or coral colony annotation using TagLab, the sort of industry standard software to actually do time series analysis on coral colony change. The ReefShape scripts are also free, and they're on GitHub. So anyone who has access to Metashape can access these scripts and install them for free and make use of this. So the hope is that this can be as broadly adopted as possible. So there's the sort of basic framing of what this process is. Let's get into the nitty gritty. So let's first talk about what you actually need to be able to use this. And much of this is the same as pretty much any photogrammetry protocol. So first things first, you need a camera system to collect your images underwater. That camera system should be wide angle. I'll give a little bit more detail on this in a minute. And it should be capable of interval photography. That means taking one photo per second consistently, so that you don't have to click the shutter every time you need to take a photo as you swim throughout the plot. You also need to have a system for collecting GPS data. And what we use for that is a Bluetooth GPS. They cost about $100, and we have them mounted up on this little kickboard kit that you can see here in panel C. I'll talk a little bit more about that too. But really, any system that's capable of collecting GPS coordinates at the surface of the water you can use it for the system. However, we've designed a custom survey that can be installed on any smartphone that's also free to use, that really facilitates easy collection of GPS data to feed into this system. The other sort of associated component to that is we use corner markers for this process. And what those are, I have one right here, if you can see it, and they're in panel D. They're these little markers that have automatically detectable targets on them. And that you use 4 unique targets for each plot. And what we do is we install these with hammer and nails at the 4 corners of the plot that we want to be monitoring. It's not critical that these markers be installed permanently. There are situations where regulation might prohibit installation of permanent fixtures underwater. And in that case, this whole system can still be used with temporary markers that you might attach zip tie onto dive weights or something, and place temporarily on the seafloor to collect your data. The only caveat with that is the time series component that I'll talk about is not really possible unless you use permanent markers underwater. The last thing that we need is scale bars. And that is something that you will need for any underwater photogrammetry process, not just ReefShape. But what we use is the same type of coded underwater markers that are all unique. Each one has to be a different pattern. And for our scale bars, we just print them on underwater paper and tape them or whatever, glue them onto ends of an acrylic scale bar. And then we measure exactly the distance between the 2 center points. Those are really easy to manufacture on your own. The corner markers are actually available from the Perry Institute. If this is something that anyone in here is interested in, check out our GitHub. I'll explain that at the very end. And these can be purchased from us. They're about $12 per set of 4 markers. And we hope to come up with a better distribution system for these in the future. But for now, if folks want these, get in contact with me and we can figure it out and I can send them to you. So those are the only materials that you really need underwater for executing this process. I'm going to talk a little bit about photographic choices because the most important part of any type of photogrammetry is that you have good images. So some considerations for choosing what type of camera system you might want to use is it needs to have a 1-second interval mode so that you can collect photos continuously. It should be able to collect RAW and JPEG images. And the reason for that is that we choose to archive our RAW images because they have much higher quality color information. And in the future, we hope to be able to develop workflows that make use of that higher quality color information to do a better job of monitoring things like bleaching and color change in coral over time. But for now, archiving those raw photos is key because that's information you can never get back. JPEGs, the common photo storage format, only stores a small amount of color information compared to RAWs. And so while they're very useful for efficient storage and processing, we recommend being able to save the raw images. Over our time of kind of figuring this out, we've found that the end result for a photo mosaic is best if you have at least 0.5 millimeter resolution. So all of our recommendations are targeted around that. That means on the reef, each pixel represents about 0.5 millimeter. And that allows us to identify coral species in most algae and other benthic organisms to genus, at least. We recommend using a wide-angle camera, or a wide-angle lens, rather. Full frame equivalent of about 18 to 20 millimeters is what we recommend. And we definitely suggest using a dome port, not a flat port. And the key thing is that your dome port is well paired with the lens. And that's why we are recommending a very specific camera system that I've extensively tested and can vouch for how high quality the images will be. Because there's a lot of, I'm not going to go into it, but there's a lot of reasons why having a properly paired dome port with your camera lens are really important. The settings that you're using are really important. I'll talk about that in a moment. What I wanted to just sort of illustrate here with this little table is that you can use a GoPro or an action camera for this type of data collection, but your models will not turn out as high quality as you might like. And certainly a mirrorless camera that's sort of middle tier and not super expensive is, in our minds, the best compromise. So the system that we particularly recommend is a Sony A6600 camera in a Sea Frogs housing with a 6-inch dome port. And that will cost right around $2,800. There's also an alternative for a slightly cheaper system that has similar image quality using a Sony A6400 camera. Much more expensive full frame cameras can provide similar levels of quality, but they're also 3 times or more as expensive. So the middle tier option is what we recommend. For a computer, to run this is standard for any photogrammetry protocol, pretty much. You need to have access to Metashape. This is the industry standard photogrammetry software. An educational license is only around $500, and a commercial use license is around $3,000. You need to have a powerful gaming type computer, and that's because the process for actually dealing with all of this data, it really needs a balance of CPU and GPU resources, and gaming computers tend to have the best balance of that. So that's sort of what we recommend when people are asking, what types of computers should we get? You should have a gaming computer with a lot of storage space, because this data takes up many gigabytes per plot. We typically use desktop computers for processing, but it's fine to use laptops as well. Just know that they will process slower, and it'll generate a lot more heat. They'll get very hot during this process, so they may not last as long. Generally speaking, we recommend folks choose a modern computer that costs around $2,000 or more. But that's sort of the baseline for us. So with all of that said, let's talk about the in-water process. And this is not very different than most underwater photogrammetry protocols. So the first step when you're beginning to set up a plot is to choose where you're going to place these. Generally speaking, we like to do our plots 10 meters by 10 meters in size. But any size is functional with this process. So the first steps are to install the corner markers, and that's finding a spot on the reef that, maybe a dead coral skeleton or something like that, that's very firmly fixed to the bottom. And it's using masonry nails to install these permanent corner markers that have pre-drilled holes in them. So you place them at the far corners of where your plot is going to be. And that usually can be done in around 10 minutes or less. Once those markers are installed, you need to measure the depths of them with a dive watch. And that's very simple. It's just holding your wrist or your dive computer up to these markers and recording their depth on a slate. After you've done that, you need to temporarily place scale bars throughout the plot. We recommend using 3 scale bars at a minimum. And those just need to be placed somewhere where they're visible from above and where they're not going to move with the current. And sometimes that might mean placing a dive weight on top of them or a piece of coral rubble or something like that to make sure they don't move. The key thing is that all of these objects on the bottom need to be visible in the photos and unobstructed. That's the key. Once those have been placed, the next step is to collect the georeferencing information. And this can be done either after you even collect your photos, or it can be done by a separate diver or snorkeler while the other person is photographing the plot. It doesn't specifically matter the timing of these things. It's just that collecting the reference data is important. So I'll talk about it here. To do that, we have our ReefShape survey, and this can be accessed from the GitHub, and there's instructions on how to set it up. It's just a smartphone app that's Esri Survey 123 with a custom survey that you can download, and you can use it without logging in. So you don't need to have an account for this. And you swim with your phone in a waterproof bag and this Bluetooth GPS on a little kickboard. Again, there's instructions for creating that setup on the GitHub page. You swim over the plot, and then you collect GPS locations corresponding to where each of the 4 corner markers are. And what happens then is you submit that data, and pre-formatted information gets emailed to you, the user, that you can plug in to our ReefShape scripts. Once you've collected the GPS data, the last key component is actually collecting the photos. And I have just illustrated here some of the key settings that you need to use. We recommend using manual mode and a shutter speed of 1/500th of a second to prevent motion blur, an aperture of f8 to make sure that you have enough depth of field in your images, and automatic ISO to make sure that every photo is properly exposed. We use a single shot autofocus mode. So you focus the camera at the first photo, and then it stays consistent throughout the rest of the process. And then we use a custom white balance that you set just before you start taking photos at the middle depth range of your plot. So that means taking your camera over and placing something white. The scale bars are a great thing to use for that. Something white in the middle of the camera frame and setting that as the white point. And that's so that the JPEG images come out without a color cast. They're not super blue-green like many underwater photos. And the last component that I talked about earlier is setting the quality to take RAW and JPEG photos simultaneously. When you're actually taking the photos, there's a few key things. It's a diver who's just holding this camera. We use just a single camera system for this. And you start at one corner of the plot and swim in a lawnmower pattern about 1.5 to 2 meters above the reef. And that works out to having about 1 meter spacing between your passes. So this graphic kind of illustrates what that looks like. You go in one direction, back and forth across the entire plot, making sure that you have collected information with a small buffer around the outside of the corner markers. And then you turn 90 degrees and do the same thing in the opposite direction. This is pretty much what everyone does for any type of underwater large area imaging or photogrammetry. We recommend keeping the camera perpendicular to the substrate. And what that means is you kind of modulate the camera angle ever so slightly as you swim to stay perpendicular to the substrate. So if you have a large coral head that you swim over, you position the camera, just hold it in your hand so that it points sort of at perpendicular to that as you go over it, and then back to flat. In sum total, most of your photos will be perfectly straight down, but we recommend just having some modulation in that camera angle. The objective is just to blanket the whole area, including vertical surfaces, with consistent overlapping photos. For a 10 by 10 plot, that usually equates to about 1,000 to 3,000 photos and takes about 30 to 40 minutes underwater. Here's just an illustration of what that process looks like, swimming at the correct distance above the reef. So that's all you have to do underwater for the first time point, and that's far more complex than subsequent time points. The beauty of using these permanent underwater markers is that when you go back to revisit a plot many months or years or whatever later, you only have to do 3 things. First, you need to locate those corner markers and clean them off. Make sure there's no algae growing on them and that the marker pattern is visible and unobstructed. Once you've found those corner markers, you need to place at least one scale bar just for consistency. That actually won't be used in the processing, but it's helpful to have just as a check to make sure that everything's working properly. And it's also helpful to use for white balancing because you need to do that each time you photograph a plot because conditions in the water column change over time. Then you just collect your photos. So you don't have to collect any of the reference information. You don't have to install anything new as long as your permanent markers have stayed in place. And in our experience, the vast majority of the time, our markers are in place. Sometimes we've had to replace a marker, but the computer process is able to handle that. So the whole objective of subsequent time points is so that you can have time series information like this. This is kind of the holy grail of underwater large area imaging because we want to see exactly how these reefs are changing over time. And having those data sets aligned perfectly allows us to fate track individual corals to see what happens to them over time. And the way, just for clarity, in Metashape, the way that this gets laid out is that each time point represents a different chunk in the project. So a single plot will have just one project file associated with it, with as many time points as you've collected, all contained in one space. And that allows for very easy comparison and data management. So I'm going to move on to our scripted processing, and hopefully I can talk about this for about 15 minutes and then leave some space for answers. So the scripted processing for ReefShape is really the crux of this, and it took us a long time to develop this, and it was a group effort. I am not an expert coder myself, and I had a lot of help on this from my colleague, Sam Marshall. So the two of us really came up with this process for working with Metashape through their Python API and developing this series of scripts that allows us to fully automate the Metashape process. So what does that really mean? It means that what normally is a many step process to generate georeferenced outputs that are aligned in time series, we distill that whole process down into one script that processes the data all the way through and kicks out our outputs automatically for us. All that's required is that we define a few key things at the beginning in a custom graphic panel, and then we can just let the computer go. So instead of then having to have, somebody at the computer for many hours throughout this process and, filling in the gaps, making sure that the next step in the process begins, the user can just enter the information at the beginning and then hit run, and everything gets finished, and then you don't have to do anything else. Your outputs are ready for you. I won't go into the depths of exactly what this process is, but it's been designed very specifically to address the needs of underwater photogrammetry, and to be as just efficient as possible. So it can be run on less powerful computers than maybe some other processes, some other protocols for this process. Here's what the main panel looks like. It's a graphic interface that pops up from within Metashape. And in that, you can just put all of the information in that you need. So the first step is project setup. And then there's a few general options. And then you put in your georeferencing information. So for project setup, you first just have to name your plot. This is just the name of the area that you're working with. And then for each chunk, because we have all of the time points arranged within a chunk, within a single project, the chunk name is the date that you collected that imagery on. And you can name it right here. And then the script allows you to enter photos through this panel as well. So you just select the folder containing all of the imagery from that time point. And then you can save the project and move on to the general panel. For coordinate system, we allow users to use local coordinates if they're not collecting real-world georeferencing information. But to automate the whole process, we use that, like I talked about, that ReefShape survey on your smartphone. And if you are using that, you select WGS84 as your coordinate system, and that allows this to be placed in its real-world coordinates. There's a few other basic options that we allow users to change, but only ones that we feel might be necessary to be changed by the user, such as how high quality the mesh is, because on less powerful processing computers, you might not be able to process at higher quality settings because it might take days. Generally speaking, we find that a medium mesh is the best happy medium, and only takes a couple hours to process on most computers. We're also able to select where we want to place our outputs from this process, and then which outputs we want to create. Do we want to create full-size products for use in GIS software? Or do we want to create special tiled outputs that are formatted correctly to be placed into the TagLab software for annotating the boundaries of coral colonies? The last panel is georeferencing. And if we're using this whole process, you just select, yes, we are using auto-detectable markers. And then you place in a text file that contains the lengths of those scale bars. There's information on the GitHub for how to format that text file. And then the georeferencing file is just what you got sent via email, the results of your data GPS collection on the ReefShape survey. You can select the columns to match up if you are entering your data in a slightly different format, but all of this is pre-formatted to use the data right out of the ReefShape survey that you get emailed, so you don't have to change any of the column formatting. And then you just hit OK, and everything runs, and it will fully georeference your plot and place it at the correct coordinates. It places priority on the scale because that's the most accurate measurement and the most critical measurement. And then using the depths from your dive watch, it will level your model as precisely as possible. And then finally, it'll adjust its XY location to match the GPS coordinates. So even if your GPS coordinates are lower quality, you still have very accurate scaling and very accurate leveling in your model. And I will open that. So that's the main workflow, and I'll sort of show a bit of a demo at the end here. The second main script that's a part of this process is for aligning chunks. And this is what happens when you've collected subsequent time points. So imagine you have collected your data in the field at a subsequent time point. You go back to your computer and you open up the project file from that plot that contains the previous time point. And then from the ReefShape dropdown in Metashape, you click Align Time Points and you're presented with this panel. It allows you to create a new chunk for the new time point and then add the photos to it. It then allows you to select the reference chunk. That's the first time point where the georeferencing was first set up. And then the active chunk is the chunk that you're working on now, the new chunk that has the new time point photos. Then if any of the markers were damaged and replaced underwater, you can add them here. And then you hit OK. And what it will do is transfer the georeferencing information from the previous time point to the new time point. It won't actually run the photogrammetry process. All you have to do then is click the full ReefShape workflow again, and it will run without you changing any settings. You can just run it and it will execute the whole process so that you have perfectly aligned data. And I'll give an example of that in a minute. So before I give you a bit of a demo for a few minutes here, I wanted to give some examples of types of analysis that this process facilitates. So the first one that I've talked about a bit is coral colony outlining. And this process spits out data in a format that's pre-ready to be imported into the TagLab software. And within TagLab, you can do analysis like this, where you can look at bleaching over time, for example. And here we have run through the full ReefShape process. We have 2 time points, and we've outlined all of the coral. At the first time point, all of these were healthy. And at the second time point, many were very heavily bleached. So this is an example of a way to track bleaching and mortality rates and recovery. Another type of analysis that can be done on this data is random point count analysis. This is probably familiar to many of you. Programs like Coral Point Count used to be used and still are used for this with photo quadrats, but that software is not really able to handle the large file sizes that you get with large area imaging. And so you can do random point counting in software such as QGIS. We have our process set up so that it kicks out the imagery and then also a region of interest that's created from those 4 corner markers so that you can just run a quick GIS process to generate random points and then begin to collect, the identification of whatever's under each point to get to do a benthic survey or something like that. The last type of analysis that's actually automated within ReefShape that I'll show you in a moment also is collecting a rugosity metric. That's the ratio of 3-dimensional surface area to 2-dimensional planar area. And with this process, this is totally automated. There's just a quick button that you can click to calculate this ratio that tells you about how complex this reef is and how high quality the habitat might be in there for various reef inhabitants. Okay, let's switch over. We have a few minutes here. Let's switch over to the demo, and I kind of want to just show you within the Metashape software what all of this looks like. So here we have a Metashape project set up with 2 time points in it. And so the way that this was done is once the ReefShape scripts are installed, you get this little drop down up here. And there's 2 main options. These are the 2 scripts that I described, the full workflow and align time points. So what I did at the first time point here is I ran the full ReefShape workflow. I added in all of my photos. I selected the coordinate system to be WGS84. And I left all of these things alone. And then I selected where I wanted to kick the outputs out to. And then I added in my scale bar file and my georeferencing file, and I hit OK. And what I wound up with is a fully processed model that is positioned in the real world. So you can visualize where it is. This is in Nassau, off New Providence in the Bahamas. So you can visualize exactly where it is. And then it gives us all of the data products that I discussed earlier automatically. The three-dimensional model. Let's wait for this for 1 second to load. Excuse the slowness of my computer here. It will load in just a second. Of course, nothing works properly when I'm actually trying to display it in real time. Okay, so here is our three-dimensional model. You can look at it and explore it in 3D. And then it also generates the digital elevation model of our plot and the orthomosaic and this boundary file that's generated from the locations of the 4 corner markers. And the beauty of this is that when I went back to this plot and photographed it again, all I did is run first the align time point script and put in the correct information, and then ran the full ReefShape workflow script. And now we have a second time point that's aligned, that's pre-aligned perfectly, pixel for pixel, to the original data. And so what I can actually do, looking at this photomosaic here, is I can toggle between those 2 time points, and I can look at individual corals and see exactly what changed. And then in analysis software, can quantify that change. Normally, that process is extremely time consuming to try to align models in this way. And ReefShape completely automates it and makes it a 1-button click process. So it speeds things up a huge amount. Okay. Let's hop back over here. So I wanted to talk very briefly before we open it up for questions about access and further information. I wanted today to just kind of give you a broad overview of what ReefShape is and sort of how it's used. But I'm sure that there are so many questions about how to functionally use this. And so what I would highly recommend for everyone, if you're interested in this, is to go and check out our GitHub page. If you search ReefShape on GitHub, it'll come right up. This is what it looks like. And it has all the information that you might need. It has the scripts that you can install. It has installation instructions for those scripts. And it has sort of a README file that has all the information, as well as a link to our white paper that describes this process in detail. So that can serve as a useful reference as well. So in the future, where we're sort of headed with this, is we have a methods paper that's in review that if you choose to use this process in the future, it's something that you'll be able to cite. There's a lot of improvements to the scripted process that we're excited to make. The main one being the incorporation of raw image data and processing using that to achieve really high quality color information in the final output. There's some additional data products that I'd like to develop through this scripted process. And then there's a training video series that I'm in the process of creating that'll sort of more in depth explain how to use the software, especially, and how to troubleshoot it and how to integrate it into your monitoring toolkit. So now that we've gotten through 45 minutes, I want to open it up for questions and a little more of an open discussion here. So excited to chat with you all and hear what you have to say. So thank you all.
Thank you so much, Will. So right before we get to the questions, I just want to direct everyone's attention to the chat where the feedback link has been placed. If you all can fill that out, that would be awesome. But Will, I'll just get started with the first question. This is more so a general question, but I wanted to make sure that this was aware of this. So someone asks, will we have access to this presentation or this PowerPoint? This was answered in the chat, but I just want to make sure everyone is aware of this. You can find this webinar on our website, on our Facebook, as well as our YouTube page after the webinar has been finished. So I just want to make sure everyone knows that. Secondly, Will, how big are the markers? Kelly is asking.
Yeah, well, I see that Matt very kindly chimed in for me. This is somebody who's actually used these a bit. They're about 3 by 3 inches. So I'm holding one in my hand right now. It's actually 95 millimeters by 90 millimeters if you're really curious, but quite small. And they're high vis so that they're fairly easy to find underwater.
Awesome. And then Emmanuel is asking for you to go back and explain the GPS data gathering, as that step is very important.
Yes, sure. So the GPS data gathering, I wish I had a good visual to explain this a little bit better. But if you go to our GitHub page, let me go over to it here. Let me scroll down here. So I think it's at the bottom. Okay, so there's a section in the GitHub page, collecting GPS information with ReefShape survey. And it explains to you where you can access this survey and how you can get it functioning on your phone. But essentially, the way that this process works is once the corner markers have been installed into the substrate, a snorkeler, or if you are doing this just as one person, the best way to do this would be to install your markers underwater, set up the scale bars, take all of your photos, remove the scale bars and go up to the surface, get rid of your dive gear, and then snorkel back out over the plot. And then what you have is this app open on your phone, and then a little Bluetooth GPS in a little baggie that's on a kickboard. And you swim over your plot and you find one of those markers, marker number 1. Each of these are individually labeled. You find marker 1, and then in the slot for marker 1, you hover over where that marker is installed on the reef, and you hit the little crosshairs icon to collect the GPS point. And then you do the same for markers 2, 3, and 4, the 4 corner markers. And then back on the boat, you'll enter in the depths that were collected for those 4 markers that you wrote down on the dive slate. So you can see that for each of these markers, there's a geopoint and a depth associated with it. And there's 4 instances of that. We've collected one of these for each of the 4 corner markers. And then you hit submit, and the system will send you an email with your data pre-formatted for inclusion into the ReefShape script.
Awesome. Thanks, Will. So next question. Have you experimented with keeping the camera constantly at an approximate 45-degree angle versus perpendicular? This has been the standard used in aerial survey photogrammetry for some time in my experience.
Yeah, so I think that, yes, you could do things that way. It's really about time efficiency underwater. So this process is really designed to be done on a single dive, and collecting all of that information flat first, and then going back and trying to do all of the oblique photos can sometimes be fairly time consuming. And so the process of just slightly modulating the camera angle as you swim, combined with the fact that it's a really wide angle camera that you're actually using, much wider than you would use in typical aerial surveying, it allows it to capture the sides of objects pretty well, even if you're just swimming and doing one set of passes and not separate oblique passes. And in our experience, the end data quality is really high using this process because you have a lot of overlap and you also have a lot of information about the oblique surfaces. But on principle, you're totally right that you could do a set of nadir top-down passes and then oblique passes after that. It's just about time underwater, and then processing efficiency. How many photos you have in sum total dictates how long the process will take on the computer. So being as efficient as possible while making sure you have no gaps in your data allows the process to be executed quicker on the computer.
Awesome. Next question from Brandon. Are there contemporaneous measurements of ocean temperature, salinity, pressure, and depth recorded during photogrammetry? Is all data publicly available?
That's a great question. Data that was collected. So much of this data has been collected in the Bahamas. And that's a whole separate conversation about data availability. For the most part, our data is not directly accessible to the public unless it's published. But yes, in a lot of cases, we do use temperature loggers that we are placed near these plots that are recording, you know, abiotic factors like that, like temperature and salinity and pH and things like that.
Sorry, apologies. Thank you. And
Okay.
then the next question is from Tom. Does ReefShape use visual features across different capture dates, or is it only relying on the ground control points being identical across the different captures?
Yeah, so that's actually a great question. So it's not using any feature for doing this question is about time series alignment of this data, of different time points of like photogrammetry capture. And yes, it is just relying on these four corner markers and not relying on the structure of the reef. And the reason for that is that reef systems are really dynamic. And what we have found is that trying to align them based on, you know, different coral heads or something like that is really challenging. And the software can't really do it on its own. And that's why we use these permanent markers, because we know that when we've placed them on the reef, they are not going to move at all. So we have four consistent points that are in the exact same place. And when you revisit, and as long as these markers are still visible, which we've found that you can just, you know, scrape it off with a plastic card before photography at subsequent time points to make it visible again. Doing that is the best way to do time series alignment. Otherwise, it's very challenging to actually automate the process.
Understood. Okay, next question. Will the automated program remove blurry pictures or pictures with other issues, or will those mess up the final product?
So right now, that's a great question. The process doesn't include culling of your photo data, but there are different ways to do that within Metashape that could be included into the process fairly easily and can also be done manually before you run the process. What we have found is that if photos are collected properly and you're using manual settings with a fast enough shutter speed, then you're not going to really have any blurry photos. Like in almost none of our data sets do we ever have any image quality issues like that. And so what we found is that just being really efficient about this underwater and making sure that you're using a system where you can set your settings such that you don't wind up with image quality issues prevents the need from doing any of that type of culling. So that's why it's not included in the process.
Okay, thank you. Next question is from Kelly. Can you link plots together that overlap to analyze a larger area?
Yeah, so you definitely can. Our process is set up just to be able to handle, you know, one single plot at a time. And so what we suggest folks do is like, it's okay if your plot is really large. We've processed with this script setup, we've processed plots as large as like, I think the biggest ones I've ever done are like 100 meters by 20 meters. So that's like the equivalent of 20 10 by 10s all stitched together. And as long as you have your computer, as long as you're willing to wait, basically, it can handle really large data sets at a time. I think it's, if you're really trying to like link up many different plots that do have some overlap, that's a little bit beyond the scope of what we're trying to achieve with this scripted process. So I think you could still make use of this while also coming up with a protocol to be able to handle that sort of like tiling format. Yeah, that's an advanced user question for sure.
Understood. Okay, Chandler says, I'm very curious about the potential to use ReefShape with autonomous or unscrewed surface and subsurface vehicles. Do you have plans to test these capabilities?
Yeah, that's a great question. Totally. It could totally be used. I think that what you're getting at there is instead of having a diver swim with a camera to take your photos, you could program an underwater drone basically to go and take those photos for you. And there's nothing in the ReefShape process that would preclude that. We haven't tested it ourselves, but I know researchers who do use AUVs like that. Um, and yeah, as long as the same, it would require a diver to install the corner markers to use this process. But the photos could totally be taken by a drone and it would be fully compatible.
Awesome. Kelly wants to know, how does this compare to software like Pix4?
Yeah, that's a great question also. So Pix4D is another photogrammetry software. Um, it's sort of a counterpart to Metashape, and it is in my experience, in my personal experience, I think it's a little bit less flexible than Metashape, and I find that most researchers who are doing underwater large area imaging or photogrammetry are using Metashape. And Metashape has a really powerful Python interface, which is how these scripts were created. And so that's why we've chosen to use Metashape for this. You would not be able to use Pix4D with ReefShape. You would need to use Metashape with ReefShape.
Okay, awesome. Thanks, Will. Nepsis wants to know, I am using photogrammetry to process data on a small area, and for scale, I've been using a ruler instead of markers. Can I use ReefShape even if my scale is not as described?
Yeah, great question. So what what using a ruler like that and not using automatically detectable markers does is that it prevents you from being able to actually automate the whole process and come out the end of it with scaled data products automatically. So yes, you could use ReefShape. We have the software. Briefly, I'll just say that we have set the software up so that if you aren't using those automatically detectable markers, you can still use that full underwater workflow in two steps. So the first time that you run the script, it'll align all of your photos and then generate a three-dimensional mesh. And then you can manually go back in, define your scale and your georeferencing, and then run the script again, and it'll finish the process and execute the rest of it to generate your digital elevation model and the orthomosaic, and then export your data products. So it can be used if you're not using those automatically detectable markers, but it just can't be automated to the degree that it can when you do use those auto markers.
Awesome. Thanks, Will. Scott wants to know, have you tried using multi-camera rigs?
Yeah, so we have used multicam rigs in the past. What we have found is that you don't actually end up with significantly improved data quality. It can be a little bit better, but what we found is that especially for plots that are this size, like a 10 by 10, you can do this just fine with a single camera setup, and the ease of use that's provided by just using one camera and having less things to manage underwater is worth it in our opinion. There's nothing preventing you from using multi-camera rigs with ReefShape. Everything will work just fine. We just recommend that folks use a single system because it's cheaper, easier to use underwater, and you can still get the data quality that you need.
Awesome, makes sense. And Selena is asking, do you have a downloadable handbook guide for using your process?
Yes, that is on the GitHub page. So if you go in here uh, and you see ReefShape white paper, you can click on that and it gives you a downloadable guide that has pretty much everything you need to know about this process. The one thing to keep in mind is that the white paper it's sort of a living document and it's still a work in progress. It has almost everything in there. But it's not like a publishable piece of work. So just be aware of that. Using the white paper, it should provide a ton of information. If there's any gaps, reach out to me, and I'm happy to help.
Great. So Jules is asking, does the program have the ability to monitor coral diseases like white band, stony coral tissue loss disease, etc.?
Yeah, so what you may have noticed is that what ReefShape doesn't address is the very specific analysis that you want to be doing on your data. And the reason for that is that depending on projects, every researcher is going to have different needs for their data. And so what we've tried to do is automate the rest of the process so that you don't have to spend time getting mosaics, and you can actually then devote your energy to doing analysis like that. So if you were using TagLab as your analysis software, yes, you can totally set it up to do disease monitoring like that. And we do that all the time at the Perry Institute. ReefShape is like, that's the software itself is not geared to that. It's designed to set you up to be able to do that.
Got you. Alrighty. So Shara says, in your initial slide about equipment, you listed GoPro. Can you speak to how it compares to the mirrorless option?
Yes. Let me just go back to that slide. So yes, you can. Yes, you can use a GoPro. Um, it's obviously much more inexpensive than the mirrorless systems that we recommend. Um, there's several downsides. One, you can't take raw images with a GoPro at 1 photo per second. It's not capable of that. It's not capable of the custom white balance that you need to be able to have to not have a blue-green color cast in your image. You can use like a red filter or something like that. Um, it's also a much smaller sensor, so you wind up with more noise in your images. And because of the way that it takes images, it has what's called a rolling shutter as opposed to a mechanical shutter. And there's sort of the nitty gritty of what that boils down to is it makes your models a little less consistent in their geometry. So you can get like models that aren't as perfectly flat, and so they can like have this sort of bowl effect. And what that means is that when you're doing time series analysis, your models might not line up perfectly, and so it makes it more challenging to do really accurate structural analysis. It's kind of a long way of saying that, like, yes, you can use GoPros, they will work. There's nothing about the process that precludes that, but it will be a bit less functional in terms of what data you get out of the process.
Super valid. Thank you, Will. Okay, Scott is asking, have you considered using IMU equipped multi-camera rigs with known interlocular distance and zero convergence to build up the capture process, to speed up, I'm sorry, the capture process?
Yeah, so that definitely could be done. The and again, there's nothing about ReefShape that would preclude the use of a system like that. Again, I've really designed this whole thing to be usable by small nonprofit organizations or researchers who have limited funding, such that they, systems like that are quite expensive, is what it boils down to. And they're also quite a bit more challenging to use and require more technical expertise. And so what we've tried to do here is make this as accessible as possible to all researchers. And there are a whole lot of good reasons that we could talk about why you would want to use a system like that. But at the same time, you can get really functional data without going that technical. And that's why we recommend just using a single camera system.
Alrighty, Jordan is asking, which version of Metashape do you use?
Good question. So ReefShape is compatible with Metashape 2.0 and up. To my knowledge, there's nothing that actually prevents it from working with older versions of it. I don't think it's using any functionality that was developed later on, but the software will not run on older versions just because of the way that Metashape does its like script version checking. So there's no reason to not be using Metashape 2.0, at least in my opinion. It's a free upgrade if you have an earlier system. The one thing that I did forget to mention is you need to be using Metashape Professional, not their basic. So the basic is much cheaper, and it does not include functionality that is critical to allowing ReefShape to be used, such as the ability to use Python scripts. You can't do that with the standard edition. So you have to use Metashape Professional 2.0 or above.
Got you, understood. Alrighty, next question is, do you have an itemized equipment list for doing this process from scratch?
Yes, and I believe it is on the GitHub. If it is not, I have it very handy and we'll upload it to the GitHub today.
Awesome. Okay. Can photogrammetry data be used to construct 3D printed models of coral reef?
Totally. So what I really didn't have time to get into is all of the amazing educational uses that this data can provide. And that can be, yes, you can easily export the 3D model from Metashape and then 3D print it. You can also export that model and put it into VR software so that you can explore it in virtual reality or in augmented reality. And there's a ton of educational reasons for that, and also just communicating with stakeholders. Like the notion of being able to toggle between two time points and seeing change happen before your eyes in virtual reality, I think has amazing implications for being able to express what's happening underwater to folks who might not be able to get to witness that themselves.
Awesome. Okay. So Matt Davies said, if I remember correctly, the last time we spoke, it was important for this script for the corner markers to be placed in the correct directional corner. For example, marker one always goes in the northwest corner. Is that still the case?
Yeah, so that's sort of a nitty-gritty question. And yes, I didn't get to it earlier. What we recommend is that you keep your markers in the same order, going like marker one in the northeast corner of your plot, marker two in the southeast corner, and going around. There's nothing within the script that that mandates that, but the reason to do that is because it makes it really easy for you to relocate your plot. At a subsequent time point, if you go down and find one of the markers, then you know what direction to look for the other ones. So it's just for ease of relocation. Yeah, good question though, Matt.
Okay, Jordan says, when aligning time series, I imagine that the file sizes of the Metashape project gets pretty large. How are you handling that?
Yeah, great question. And very briefly, another thing that I kind of didn't get to touch on because time limitations here is within the ReefShape. Oops. Within the ReefShape dropdown in Metashape, we have a little tools panel, and there's a whole bunch of useful scripts that are most of which are included within the two broader scripts, but there is one called Clean Project, and what that does is it goes through the chunk that's active, whatever time point you're working on, and it deletes all unnecessary intermediate data products, so that it very much decreases the file size of these things. And so what you wind up with is, you know, this that has 2 points. I think the file size for the processing here is like less than 5 GB grand total. So it makes it much smaller. Otherwise, this could balloon into like hundreds of gigabytes very quickly. But yeah, this clean project script that we have here is really helpful for trying to cut down on file sizes and helping with storage space.
Awesome. Okay. Next question is from Chandler. Is anyone working on analysis tools for rubble versus live or bleached corals?
Yeah, there's a whole bunch of people working on different kinds of analysis tools. Again, what I'm trying to do here is sort of like do everything but the analysis, because to be able to do analysis efficiently and consistently, you really need to have a process that gives you repeatable data products. And that's what this is totally designed to do. So I would say that that's a little bit outside of the scope of what I'm trying to achieve with ReefShape. But if you're using ReefShape, you can certainly address those questions with various types of analysis tool sets.
Wonderful. Thank you, Will. Okay, so before we proceed with any more questions, I will drop the feedback link one more time into the chat. And if you all can complete this link, that would be awesome. I don't think I see any more questions. So, Will, if you don't mind, I guess we can just allow a few more seconds, maybe, if anyone wants to get any more last minute questions in there. I know we just went over a really good amount, but just want to give everyone a fair shot. Uh, doo-doo. Okay, I see a raised hand. One second. So I'll allow Brandon to talk. Oh, sorry. Brandon, is your hand still raised? Do you still need to ask your question? If I don't see your hand go down. Okay, you are muted, so I think your question has already been answered. Okay, let me just check to ensure that there are no more questions for you. Well, I don't think that there is. So, with that being said, thank you again, everyone, so much for joining us today to learn more about ReefShape, discover the future of coral reef monitoring. Also, thank you again so much to you, Will, for this wonderful and very informative presentation. For more information, please visit our website at perryinstitute.org and follow us on our social media channels at Perry Institute for Marine Science, including Facebook, Instagram, Twitter, and LinkedIn. And we hope you will join us again for our future webinars. Thank you again, and please enjoy the rest of your day. Bye, everyone.
Thank you all.
Hi, Will. How are you doing?
Good. How's it going?
Hey, pretty good. This is Lino Davis from the Bahamas. Um, I wanted to ask if you have to check those disease stuff after the fact. Like do you need like human eyes to check it, or can you program that in?
Yeah, so that is still sort of on the topic of like specific analysis pipelines that you want to be doing. As of now, I don't know of any sort of like AI related tool that can ID those diseases automatically. That is like that's a whole other topic to cover, is like AI related analysis of photomosaic data. Um, so
Okay.
right now, the way to address that is like when you are doing your analysis in a program like TagLab, um, you would go through and mark a coral that you see visually as diseased and what disease that is. So it is manual, but it's in that case, it's kind of the same type of data you'd be collecting underwater, but with the ability to do like time series change much more easily because all of that data is pre-aligned and you can see what happens to that individual coral colony through time and like measure the change in like disease prevalence and whether it survives or not, that kind of thing.
Question was, do you have a price list or like an equipment list attached to that guide that
Yes.
says like this is everything that you need, along with like numbers of divers and stuff like that, like how the agri manual is?
Yes. So yes, a lot of that is in the white paper.
Okay.
The upcoming publication will also address a lot of that.
Okay. I look forward to seeing it. Thank you, Will.
Yep. Thanks,
Have a
Lino.
great day.
Thanks, Angelino. Okay, well, I think those are all of the questions. So thanks again.
Sure.
Bye, everyone. Have a great day.
Take care, everyone.